Okay, I will share my screen. Okay, so yesterday we were doing some commands. No, in that we were trying to do how do we differentiate from the versioning part. So that I will show it like which versions, the timestamps. Whenever we create a table or we do add some column family information, the timestamp only maintains the version information. Okay, so each column family which we are adding into a table will have the versions, right? So I have changed the versions to 4 yesterday, then tried to retrieve the values, add some values into the fourth version and try to retrieve only that version information. So that I will show it because it didn't work yesterday. I'll show it now. Okay, so I have a list of tables. In that I will take a course table. Okay, so if we see the course table, I'll see the description. So there are two column families in that, course info and course time. Maybe a course info I have changed it and I checked it. I will try to change the course time and show you. Okay, we'll also see what are the contents of the table. Scan, course is the name of the table. So this is their timestamp information, time afternoon, forenoon. Two cells are there, afternoon and forenoon. It is having all these two information. Okay. Now what I will do, I will add some new version to this course time. How do we do? Alter course, comma. We will say the name of the column family is course time. That we have to give it in quotes. Then versions as something like 3 or something we can give. Okay. So it is getting updated. Then if we check our description, the version for the new for the course time is changed to 3. Okay, so we'll also see the details. We know that 2 p.m., 10 p.m. is there for afternoon and forenoon. What I will do for this version, we will list it out and check it. Then we will put some data into this version and check it what values are coming, and what values are present for the older version also. Older version was 1 and the new version is 3. Okay, so how do we get it? We use get command, get course, and the row key is row 1 here. So it's, since it is a string, we have to give it in quotes only. Otherwise, if it is integer, we can give plain, no need for quotes. Then which column I'm going to retrieve, I will give it column and the column family name. Course time is the column family name, and the versions is going to be 3 now. So now it will give both the information, because only version we have changed for that. Now in this version I will add, it is presently in 3 version. Now I will add the data to it. Okay, I think we also have not seen data, how to add data to a particular cell. Okay, using put command we can do that. Course row 1, save. This is the column family name time. So I will add it for say AF new value. Okay, comma 5 p.m. I'll add. Okay, for the column family time AF, which is already present for this cell, I'm going to add a new value 5 p.m. Okay, so it is added. If we check it, scan it, it is changed to 5 p.m. here. Okay, then how do we get which information is present? For that, I have to give the get course, and we can also get the particular cell information also. So I will write this. Okay, row 1, this one, enter. For the, for the version 3, it is having all this information. See, for AF, two informations are there, like 5 p.m. and 2 p.m. for the cell AF of the column family course time. And if we wanted to see the without, I mean, what was the earlier one, then you can directly give like this. Then earlier version information was not without the not without the 3 p.m., 2 p.m. Sorry, it is the latest version information only. Say if we give it 1, this is also the latest information only. So 3 is having all the information of whatever is modified earlier one, but all other version is giving the updated information. This is how we can differentiate it. One, you can also retrieve it for a particular cell like this. In the course time, if you give it as AF, then the particular cell will be retrieved. Okay, is this okay, ma'am? So how
Yes,
can we? Sorry, ma'am.
yes, ma'am.
Okay, Usha ma'am, is it okay? Usha ma'am is there. She is.
Yes, ma'am. I'm only replied. Okay.
Okay, ma'am. So this is how we can retrieve the particular version information. Latest is containing all that. Otherwise, it will come contain the other whatever is modified. Okay, so this is how we can find out who has added what versions, and also we can do a analysis only on for the particular version in version content. Okay, so that's all in HBase. So we'll move to Sqoop. Only theory I will take it today. Okay, then that is all for today. And any other doubts in HBase? I'm sorry, I've not missed to upload the content yesterday. I will do it after the class today. You can refer it. Okay. Any other doubts in HBase? And the Java programs also, other two I will upload. You can work on that and tell me any doubts you have. We will do that. So anyone wants to add why we use Sqoop? What is Sqoop? Any idea? Spark, I will take it from next week. Spark is another similar framework to Hadoop. So it is a little more architectural wise, conceptually little same like, not same, like similar like a Hadoop. We cannot say it as a replacement, but it gives 100 more works like Hadoop only. Okay. So all whatever the technology which we are learning now, Big Hive, HBase, MapReduce, and Sqoop all works on top of Hadoop. So uh, S- Spark can work. Spark is another technology like a Hadoop. So I wanted to take it later, little more detail. This Sqoop is simple. It is like what it is. Can I move? move on. Any doubts if you can ask me, okay? So Sqoop is like retrieving the information which are distributedly present. Not only the flat files can be from any databases, right? So we saw in our I we have the connector to connect to our MySQL where we store the schema. Right. So similarly, if you wanted to take information or the datas which are distributed in different databases. So earlier everything is in the databases only. Traditionally, everything goes and sits in the databases. Now there are different kind of databases have come, which are the NoSQLs, traditional also graph based, key value pair map based, all those we have seen, right? So in order to take all those information into our hdfs, we use this framework called the Sqoop. So it is nothing but the SQL to Hadoop, and it is also derived in this way itself. Okay, SQ and OOP. Okay, it says SQL to Hadoop. That's why it also had the name as Sqoop. Sqoop is designed to support bulk import from the other any databases, traditional databases. So it all comes with a connector. The connector will be written in the JDBC. JDBC will do a connectivity between the databases and our any programming languages or any framework. So they have the connector which says not only for say MySQL databases, it has the connector for NoSQL databases or any other data warehousing enterprises warehouses also, or any SQL databases also. They have the connector. Using that connector, we can make a connection between our the Sqoop framework and retrieve the data
Ma'am,
from the. Yes, ma'am.
ma'am, are you showing any slides?
I'm not sharing. Okay. Sorry. Yes, I'm sharing. Now visible, right?
Yes, ma'am.
Okay. So again, Sqoop derives from the two SQL to Hadoop. Okay, SQ and Hadoop OOP. That is the name how it got, and it is for the bulk import any data from any other databases, database information, not the flat files. Flat files, I mean, it is not only the flat files that we store in Hadoop. It will be the input data can come from databases or from the flat files or from NoSQL information or from any warehouse. So for that they have the connector written for each connectivity with a if it is for a SQL databases, it will be a similar connectivity, or for MySQL, Postgre, Oracle databases, different connective connectors will be there. Using that, we can import the Sqoop a framework, or the environment will help us to import the data to our HDFS for further processing. So it is based on the connector architecture, which supports the plugins to provide the connectivity to external systems. So why Sqoop came into picture? For the idea that how do we import data from which are unknown and which are in different databases. Okay, that's when the Sqoop also came into picture. See, if you see on Hadoop, all are written on the Hadoop itself with HDFS, MapReduce and all. Okay, uh, HDFS is there. MapReduce is there. So all other frameworks like Pig, Hive, HBase, all this came into picture one by one because they don't want to write MapReduce jobs in Java. So Pig came, HBase, Hive is also there. S- So some company, community they wanted to do use their that Yahoo they know pig Latin scripts, so they want to write pig Latin use theirs and or do the use the data in HDFS, use the distributed environment, so they came up with that. So like HBase, where we can have a faster lookup information, so HBase came into picture. Similarly Hive, who knows the SQL can use Hive like that. So all this were written over the top of the HDFS itself. Why I came to say is whenever the requirement comes or whenever they wanted to satisfy some needs, all are written over our distributed environment to support the data analytics, not data analytics, the data processing functionalities. So Sqoop also came into picture because we wanted to import data not from a flat file, from a different environment itself, different kind of a system itself. Okay. So more on Sqoop, it is a tool itself. It is like we can give like a hive command, shell command we give no hive hbase and pig, like that itself we can give a Sqoop command itself, and it will do all the with the commands, it will do all the processing. So is designed to transfer data between Hadoop and a relational databases or mainframes. So it can do both ways also. It will take the data from RDBMS, store into Hadoop, or it can do the other way also. After the processing is done, mapping and all is done, then it will store the data into the RDBMS. Only thing is it has to maintain the schema information. So schema, which is because once it comes to the Hadoop, we will consider it as a Hadoop will consider it as a flat file. But when it goes back to the RDBMS, then it should be considered with the schema. No, so then only it will be properly inserted into our RDBMS. Right. You can use Sqoop to import data from relational database such as MySQL, Oracle, or any mainframe into the distributed the HDFS, transform the data into Hadoop MapReduce and export the resultant data into the RDBMS only. Whatever I'm told, they have explained it. So this process can be automated, relying on the database to distribute the schema for the data to be imported. So schema information has to be preserved somewhere. That shall be kept in the Sqoop tool as a metadata. Okay, so that we have seen in Hive also. No, we keep the metadata information, but that is not this one. That is different. Just we cannot compare Hive and Sqoop, but just saying it, we have to preserve the schema information, which is nothing but a better metadata information, which provides parallel operation as well as fault tolerance. So data will not be in our Hadoop. We are not overloading into Hadoop. Whenever we need, we can take it from any other databases and put the result into back into that itself. So this way it is fault tolerant also. No, so one it goes down, another we no need to. But Hadoop also is HDFS is also is good in fault tolerance. So some more added advantage they are describing it, and this is a command line tool suite. That's what I told before. So you can give Sqoop with the commands, then it will work. Okay, furthermore, the architecture. So, this is the older one, Sqoop 1, and Sqoop 2 is the newer architecture. And the Sqoop 1, there is not many things. There is no client server architecture supported. So, it is all like a client will directly client, this is a client, he will directly write the Sqoop tool or contact the Sqoop framework that will have a connector to query to import the data from the databases, and it will do a map task. Actually only map task is done in Sqoop. Okay, it does a map task and store the data into the HDFS. Okay, whereas in Sqoop 2, so there they have developed to support the browser also, so client server architecture. So the overload will be very less. We don't take the tool and make it overload. Anyway, client server architecture is that way, right? Many client also can connect to the servers, whereas here it will be traditional. It is like a single client will connect it, and the other kinds have to wait it if the architecture is not supporting for multiple clients. But if case of client server architecture, many clients can connect it, the server will handle the load, and it will start a map reduce, sorry, not map reduce, map task only, and retrieve the data from the warehouse and store it into a HDFS. So there is something like this is the architecture Uzi. So these are the APIs supported to perform all these jobs. So REST is the API, and UI is the user interface, which is a kind of a browser that the user can use it to do that. Same like we browse through our HDFS, right? HDFS for our file system. Sqoop also can have the is also having the browser environment. And job management manager, same like in Hadoop, will take care of the jobs which are scheduled. Okay, so connectors and connector manager will take care of the connection between the uh, the RDBMS and to the Hadoop. So connectors we will download it. We have downloaded connector for Derby and MySQL node. Like the jar file will be there. That will have the JDBC implementation between the RDBMS and the HDFS. Like from the RDBMS to the application. Here you can think of HDFS. Okay. So metadata repository that stores the information about the schema. Okay. While we are storing it back to the RDBMS, then we need the metadata information, schema information, that we have it in as a separate repository itself to store it. Okay. So furthermore, so they are differentiating about the whatever I told it is there. So only mapper job will run, reducer job is not required. It is like just preparing our data from the RDBMS. Mapper does that job only, no. So prepares the data from the RDBMS and stores into the HDFS in the distributed format. So Sqoop architecture with mapper they have given. Sqoop provides command line interface to the end user and can be accessed using Java APIs. Only map phase will run and the reduce is not required because complete import and export process does not require any aggregation. So you, I hope you remember what we do in the reduce we do a sum of all the information, no, that is not required, that is the result. So that is why reducer is not working here, it is only import and export. Okay, any doubts till now? Am I going fast? Shall I slow down or is it okay? Any doubts till now?
No, ma'am, it is okay. You can carry on.
Okay. Okay. So this is an enlarged diagram of the same thing. So this also I have explained. So what is CLI? CLI command line interface. Yeah, command line interface that we use it in our terminal. Otherwise, using through the browser also, a user can give commands to run a scoop environment. Scoop to retrieve the values from the database into the HDFS. So all these are this one. This is the REST API, which will be little new. You can learn later. Also, user interface and job manager is required to when every map task if it is started, then the job will be associated with no. The job starts. Job manager starts a map task and gives a job ID for that. So that will be taken care. How many map tasks are running that and there is another picture which will tell how it is actually happening. Okay, I will show that. Then Sqoop server manages all the thing and connector manager metadata. Okay, so this is again the features. Whatever the features which were not supported, there was a workaround which is made in the Sqoop 2. Okay, that's what we have given. Like connectors for all major RDBMS, it is supported, but in Sqoop 2, it is not supported. So, how do they support it? Using the JDBC connector. So, Sqoop 2 means it is the latest one with the client server architecture. So, it is not supporting for connection with every databases or every database management systems. So in that case only they have come up with the connector part. Okay, the connector should work on the other JDBC compliant database. Our performance might not be comparable to specialized connectors in Sqoop. We cannot compare the connector information. That's what's in it. One thing is the JDBC should be MySQL, Postgre, Oracle, and all, or compliant with JDBC. So you can write a Java code, you can write a JDBC code to make a connection with MySQL, everything because they are compliant with this JDBC. I hope you understand what is JDBC, Java Database Connective. Connector. Okay. So for in case of a security integration, this both are supported. Data transfer from RDBMS to Hive or HBase. So this also on the top of the HDFS. This is supported, but in case of client server, they do it in a two ways. One is like load into Hive or HBase manually using appropriate tools and commands such as load editor. That we do it for HDFS also now itself. And the data transfer from Hive or to the backwards, that is not supported in Sqoop 1, but in Sqoop 2 also is just not supported. But we do it using the workaround, like either as a text file to approach, extract the file. We will do all these things, okay? Later after installation, we will do the commands. We'll see how do we load it and unload it. Okay, so this is how the flow is. Uh, so we Sqoop importing the data into the Sqoop. So it is from, we give a Sqoop command, gathers the metadata information, which is the schema information, and each will be the information is divided, and the mapper job will start for the divided information. Then once the output of the mapper will be stored into our HDFS storage. So this is importing from RDBMS to HDFS. This will be, here will be the RDBMS, and this is HDFS. Okay, and the other way, exporting data to the RDBMS back will be the same way, whereas the HDFS information will be sent to the mapper job, which is a Sqoop job that will collect all the information together, and it will also check the metadata in order to store it in our RDBMS. I think that is all. So these are some basic commands which we'll use to import command. We will first we have to make some configuration changes in our map red. Okay, because it is also dealing with the map reducer job. There we have to change some configuration map red site.xml that we have to change, and we also have to change the yarn. Okay, because that take cares of all the executions, so yarn, and after that we can do this. So this some basic commands they have given using the connector fn connect JDBC connector, the MySQL database information you can give. This is the name of the table, employees, and username and password, then it will work. So this we will see it on Monday, okay, after installation. You can import and import all tables you can do, or you can do it incrementally also, one by one, giving a table, if I mean giving a value set of uh, what which is a range that till that number of records it will import it, and it will store into the HDFS. And import all tables also you can give, or specific tables, okay, and export it. So this we will see it on Monday. Okay, that is all from my end today. It is less, but that's all. Any doubts? So how was your project going on? Have you all started it? You are all prepared for the zeroth review?
Yes, ma'am.
Okay, what about others?
Preparing, ma'am.
Pooja is prepared.